Hello everyone, I am Aditi. This video is about hashing techniques and record distribution, which is my FSDP TEC. Now, let us see what we are going to learn in this video. Introduction to hashing and collisions, hashing functions, record distribution, in record distribution, distributing records among addresses, predicting the distribution of records using Poisson function, predicting the collisions for a full file and the packing density. Now, what is hashing? Hashing function produces an address every time you drop in a key. Best hash function have minimum number of collisions. It also referred to as randomizing. In the diagram as shown, as the key is passed to the hash function, that hash function generates the smaller value called as the address. Best function is that which have minimum number of collisions. Now, what is collision? When two or more keys are passed from the hash function resulting the same address. As shown, the Michael and Toby having underscores hash function having the same address, that is the 2, which is shown by the red lines. There are different hashing functions. Different hashing functions are as follows: direct hashing, folding method, mid square, division method, and radix transform. Now, in the direct hashing, no algorithmic manipulation results no collision. So every key has a particular address, but it is limited to certain range. Because large number of address, it is difficult to manage. Next is the folding method. Key value is divided into parts whose size matches the size of the address. For example, here is for example 7418 7148, and the address is of 2 digit or bytes. So first we have to fold this 7418, that is 71 and 48, and we add, that is 71 plus 48 is equals to 119. But as we have the 2 digit address, 2 bytes address, so the one is discarded here. So the address is 19. Alternative is some parts of the folded key are reversed and then summed, that is reverse the part before adding, as shown in the example. Hashing function of 3205, first the 05 is reversed, that is 50, and then add, it is equals to the 82. This is the address. Now, mid-square method. Key squared and address selected from the middle of the squared number. First, as shown in the example 7418, first we squared 7418, that is 51093,904. As suppose we want to take the 2 bytes address, so we take the middle, that is 93. If we want to take the 3 byte address, then if we take we can take 093 or 939 as the middle. Problem with the method is does not distribute the key uniformly. The next is the division method. Next is the division method, that is the h of k is equals to k mod m, where m is the size. If m is the prime number, less collision will occur. As shown in the figure, H 3205 percentile 97 or mod 97 is equals to the 4, as 97 is the prime number, so less collision will occur. Next method is radix transform, converting the key to the another base value and modulo by maximum address. As shown in the example, decimal 453 converted in the base 11, that is 382, and address range is from 0 to 99, then the max address is 99. So 382 modulo 99 is equals to the 85, that is the address. Distributing records among addresses. There are the three cases: best, worst, and acceptable. In the best case, the mapping is one map one. That is, ideally a hash function should distribute the records in the file so there are no collision, which is the best case, and the distribution is called the uniform. As shown in the example, object 1 mapped to the 4 address, object 2 mapping to the 16th address, object 3 mapping to the 68th address, object 4 mapping to the 125th address. That is 1 to 1 mapping. There is no collisions. Case 2, which is the worst case, as the record shares the same home address, resulting maximum number of collision. As shown in the example, records A, B, C, D, records A, B, C, D sharing the same home address, that is 4, sharing the same home address, that is the 4. So it having the maximum collisions. So it is the worst case. Case 3. Records are somewhat spread out but with few collision is acceptable alternative. That is, as shown in the figure, Michael and Toby having the collision at the address second, but rest are having the single mapping and single addresses. So it is the acceptable case. Let us see the prediction, the distribution of records and collision using example. For this, we use for prediction of the distribution of records, we use the Poisson function. Poisson function is to estimate the probability that a given address will have certain number of records. We can also predict the number of records that we will have certain number of records assigned, denoted by P of x, which is the probability. Here is the formula that probability of x is equals to r by n to the power x into e to the power minus r by n upon x factorial, where capital N is equals to the number of available addresses, r number of the records to be stored, x number of the records assigned to the given address. In general, if there are n addresses, then the expected number of addresses with x records assigned to them is n into probability of x. Let us see the example. Hashing function will distribute the records randomly and you want to store 10,000 records in 10,000 addresses. How many addresses expect to have 0, 1, 2 records assigned to them? So from the given problem, the n, which is the number of the available addresses, that is 10,000, r, which are the records, that is 10,000. So r by n, which is the packing density, is equals to 1. Hence the proportion of the address with 0 records assigned should be, that is the probability with the 0 records. Putting the values into the given formula is equals to the 0.3679. So the number of address with no records is equals to the capital N into probability of 0 is equals to 3679. Similarly, we can find the probability of 1, probability of 2, and the number of addresses with 1 records as well as 2 records. Here x is equals to 1 have exactly 1 record assigned. So there is no collision. The 1839 address with the 2 records. If address have a space of 1 record, then the collision occurs. So 1839 records will fit and other 1839 will not fit. Another example is hashing function will distribute the records randomly and you want to store 500 records in the 1000 addresses, assuming that only one record can assign to each home address. How many overflow records could be expected? As given from the given example, n is equals to 1000, r equals to 500, r by n is equals to 0.5. Hence, the proportion of address with 0 records assigned should be probability that the 0 records assigned is equals to 0.607. By putting the values, we get this. uh, the number of addresses with no records, that is 1000 into p of 0 is equals to 607. Similarly, we can find the probability of 1, 2, 3, 4, 5, and the number of addresses with 1 records, 2 records, 3 records, 4 records, and 5 records. We have to find here the overflow records. Here we only find till P of 5 because if we find P of 6 and 7, it is negligible. So we have find till P of 5. Overflow records, the formula for overflow records is 1 into n into P of 2 plus 2 into n into P of 3 plus 3 into n into P of 4 plus 4 into n into P of 5. Now, as given, n is equals to 1000, which is common for all. So 1000 we take a common, and after calculating we get that the overflow records are 107. And the packing density. What is packing density? It is the ratio of number of records to be stored to number of available address. The more records there are packed into a given file space, a collision will occur when a new record is added. Packing density is equals to R by N, which is we use in the Poisson's function. Hope you will like the video. So here are the questions based on the topics we have discussed now. What is the direct addressing? What is the use of hashing? The two different words that are synonyms. What is the simple uniform hashing? And what is the formula for Poisson function applied to hashing? If you like, press the like button, drop the comment and share it. Thank you for watching.